Hey guys, this is day 9 on Binomial Theorem Part 2. One quick note, my roommate might be a little loud, so just ignore any noises you hear there. So apologies on that, but it is what it is. He's playing games right now. Oh well. Alright, anyways, day 9, Binomial Theorem Part 2. So let's recap for a second. This is the formula that we kind of came across when we got to the Binomial Theorem from Part 1 back on day 8. And so this allows us to easily expand out any binomial that is raised to, say, a power of 3, 4, 5, 6, so on and so forth. Now, we talked about expanding the whole thing. The process is tedious, but once you get the rhythm of finding the first term and then the second term and then the third term, it becomes pretty straightforward. It just takes a little bit of time to get used to. Here is where we are now talking about being specific and being efficient with our time. Sometimes we don't want to expand the whole thing. Sometimes we want to find a specific term, say like the fifth term or the term that has x to the 7th power, something like that. So let's take a quick example. There's two ways to go about it. Either we find out what the coefficient is, or we find out what the term is. The second one's going to be harder. We'll do it on the next page, but let's start with the first part where we're given, hey, you got the binomial quantity. It's being raised to a certain power. Find the term that, or the coefficient of the term, like m to the 4th or m to the 3rd. In this case, we are trying to find m to the 6th power of this binomial provided here. Okay, so let's go back. Let's do a quick recap of what we need. Recall that we have the terms. If I were to write this out, right? If I were to kind of go from the top here, you would say that to copy and paste here, this 5 is going to be my a. That's going to be negative 5, right? So keep in mind. And then the 9 is going to represent the n. So if we kind of go back and forth between this part and what we're doing right here, here's what we start off with on the first portion. So the first portion we get is going to be n, which is 9. We always start with 0 as the j portion, and then we're going to do the a portion, which is negative 5, but we raise it to 0, so effectively it cancels out, but I'm just doing this for the pattern recognition for your benefit here. And then the x, or the variable here, is going to be m. Heads up, just recall this x could be another coefficient in front. It could be like 3m, it could be 2z squared. You got to be pretty fluid and flexible depending on what's given to you there. So it's going to be to the 9th, and then we continue on. Increment by 1, increment by 1, and an increment just means that go up by 1, decrement means go down by 1. So that means this becomes 8. And the pattern continues, so on and so forth. Okay, so let's do some analysis here. We want only the term that has m to the 6, right? So really all you want to focus on for now is figuring out this term here, and then you'll figure out the coefficient later. So if we kind of go through the pattern here, right, the first term is m to the 9. The second term is m to the 8. So to get to the 6th term, we can kind of follow this pattern, right? So if we count like m to the 9 is the first term, m to the 8 is the second term, m to the 7 is the third term, m to the 6 is the fourth term. We can easily count here, right? But is there a faster way to get to that point in time? I want the fourth term. Well, let's think about what we were asking for in the first place, right? We wanted m to the 6, and we knew that the binomial was m to the 9. So how could I use 6 and 9 to maybe get to that fourth term? Well, simply put, we could say m to the 9th term, right? Where that exponent is 9. M to the 6th term, exponent is 6. If I subtract the 2, if I take these two and subtract them, we are left with 3. And what I can do is say, oh, we can add 1 to that. It's kind of like when I ask, like, what's the good example? If I use spreadsheets, it's a little bit easier this way. If you're on like row, say like 2, and you want to get all the way up to like row, let's do an easy one, like row 10, right? If I asked you like how many entries were there between row 2 and row 10, you wouldn't say 8. You'd actually say there's 9. 10 minus 2 is 8, but you counted extra for one of them. So think about it. Row 2, row 3, row 4, row 5, row 6, row 7, row 8, row 9, row 10. There's 9 entries, not 8. So we got to add that extra lost number there. So we can use the same tactic like we do there, and then we're left with this idea that, oh, it's when the j term, right here, when the j term is actually equal to 4. So if I rewrite this whole thing out, really all I care about is 9 to the 9 choose 4, and that means here we're going to have negative 5 raised to the 4th, and that means it's going to be m to the 9 minus 4, which is, or 9 minus 3 in this case, which is actually going to be to the 6th power. Again, hardest part about this is just knowing how to count. I know that sounds really dumb given that we're in math analysis and we should know how to count, but breathe, take a step back. Again, it's the difference of what's the difference of two numbers versus how many values are there between, say, the second term to the ninth term. There's actually 8 numbers in between. It's because we're counting out an extra one. So all we really care about is the coefficient, which means we actually do not need this term. And so now we just calculate this, right? So this top portion, we can go ahead and utilize that calculator to help us out a little bit. But just to, go back to some basics here. We got 9 factorial over 4 factorial, quantity 9 minus 4 factorial, multiplied by the negative 5 to the 4th power, right? So some easy ways to go about it is some tricks. We can do 9 factorial over 4 factorial, 5 factorial, times negative 5 to the 4th. What we can focus on is this 9 factorial and 5 factorial, right? If we were to almost distribute it out as if we said 9 times 8 times 7 times 6 times 5 factorial over the 4 factorial, 5 factorial, quantity this, we'll notice that, hey, that'll cancel out. That's a little trick we can use there. And then we continue on with the rest of the problem. So you got 9 times 8 times 7 times, times 6 divided by the 4 factorial, and then negative 5 to the 4th. And then if you want to try plugging this into your calculator, that works as well. Again, from the starting point, you could originally do this on Desmos or on your graphing calculator, right? But it's sometimes nice to just kind of reduce things down and then be like, oh, this is not too bad to plug in now. And then you go from there, okay? All right, let's move on to the second page where we now talk about, we want to find a specific number term, right? I want to find the 5th term, the 6th term, right? So if you write this out just like we did with binomial theorem, we can start off with saying, hey, here's kind of like the x, here is the a term, here's the n. So we would start off by saying, we're going to do 12 choose 0 of the a term to the 0 power times the variable raised to the final part. That's the first term, right? Then we get 12 choose 1 for 4 raised to the first power, w raised to the 11th power, right? So if we think about it, right, this is the first term, this is the second term, and so on and so forth. So if we make a relationship, we can say the first term is where j is equal to 0. The second term is when j is equal to 1. Oh, the 5th term is when j is equal to not 5, it's when it's equal to 4. Then we can proceed from there. Then we could say, okay, so if I really care about when j is 4, well, that's 12 choose 4, take the a, raise it to the 4th power, and we take the w raised to the n minus the j term there. So that's going to be w raised to the, make sure we got that set. It's going to be, blank it out here for a second here, guys, hold on, to the 8th. And I believe that should be squared away. Let me just double check that. And minus j. Yep. And again, if you need a sanity check, like go through it, right? So the first term is when it's w to the 12. Second term is w to the 11. 10 is when it's the 3rd term. Counting down, 9 is when it's the 4th term, and 8 is when it's the 5th term. It's okay to doubt yourself. Double check. Go do the concept one more time. You got the whole spiel. Good to go from there. Okay. So then we do the same process as we did before. We think about this as 12 factorial over 4 factorial a factorial, because 12 minus 4 is 8. Raised to the 4 to the 4th power, multiplied by w to the 8th power. And then we start simplifying things down from there. Plug into your Desmos calculator, your graphing calculator, you go from there. So again, this part requires a little bit of extra logic, but it becomes less tedious than the whole binomial theorem. Binomial theorem, when you apply it, or when you expand the binomial raised to an exponent, it's tedious, but it's once you get the pattern, it's not bad. Here, it's more like, oh, I just need to find one of those terms, but to logically deduce that, it's going to take a little bit of front-loading the work effort there. Okay, give it a shot in the practice set. You should be all squared away.